Yeah. Welcome everyone.
Yeah, I had a doubt. Question.
You had a doubt with the question. That's amazing. I just wanted to welcome you. We're going to talk about nonlinear equations again. So, as per the plan, we were going to spend 2 sessions on nonlinear equations. And maybe we can start with your question. So, Singh, you have a question?
Yeah.
That is. Okay. First, as it's not on nonlinear equations, I think this question is for linear equation the one variable part. So it should be yeah, I have a good memory. This is the question you're asking about.
Yeah.
That's amazing. First off, I'm really happy that you asked the question. I mean, in general, I'm happy when people ask questions. So this is on linear equations in one variable. It talks about a guy named Hector. So the bin has 24,000 something bushels of corn. That's how much the bin has. After 5 hours, then you have bushels are now 19,350. And now the question is asking how much, how many hours will it have passed when Hector has, let's say it's normal B, 12,840 things in the bucket. So that's not a bad problem. Here you can assume that the rate of change is linear. What happens at hour 0? That's a question for you. Yeah. Yeah, good. It's 24,000. So 24,000 is at h is equal to 0 at the start of time.
Yeah.
Okay, and h is equal to 5 gives you 19,350. And you can assume that the behavior is linear. Then you can think of these two as 2 points on a line. So 0, 24,000, and 5, 19,350. And you can find the slope of this line. So can you tell me what the slope or the rate of change in this case would be? Step by step. If you don't remember, it's okay. Well, it's usually the rate of change in y divided by the rate of change in x. We chose b to be the output because time is an independent variable. But this is just a matter of taste. You can do it the other way around, but that would be more unnatural. Use a difficult word. So you just measure the slope. And the slope is measured as follows. So y2 minus y1 divided by x2 is x1, which is the change in the y with respect to x. So I hope that at least is good reminder. And so this is your, let's say this is your x1, y1, and let's say that is your x2 and y2. Then in that case, you just plug in. You get 19,350 minus 24,000 divided by 5 minus 0. And this would make sense because this would be negative. Negative value, and here it would be a positive value. So the slope would be negative. And it makes sense because he's removing core in this case, so it makes sense to have a decreasing amount. So at least the math makes sense in some sense. So 5 minus 0, 5, and maybe if you have a calculator, you can compute that. So that will give you some slope. Let's call it m. And do you know how to find the constant, which is the y-intercept c? So we know that each line can be represented as follows. And so, if we have this and we have m, we need to find c. And we know that we can find c always when we plug in 0. If I plug in x is equal to 0, I get c, because I get m times 0 plus c. This is just a refreshment. So I still need to find c, but this is not too difficult, because this is my c, as you can see. So this linear model is just m, whatever you compute. If you have a calculator, maybe it's a good idea to compute it now. And then you multiply it by x, and then the constant is just 24,000. And now you have an equation in x and y. And you have a y coordinate, and you want to find the x coordinate. Then it is not too difficult. So you just write here 12,840 as your output instead of y of x. And you just find x. So in that case, you would get 12,840 minus 24,000 divided by m to be your x, where m is the value that's here. But since you're in the SAT and it's nice, you could also try to plug in values here. So without knowing the c, you just know that, let's say, with 5 steps, I move this amount. Then what happens if I move with a smaller step, and so on and so forth. So that's also something you can experiment with. And I don't have a calculator on me right now. Okay, maybe I do. And but we compute the flow very quickly. We'll get 19,350 minus 24,000 divided by 5. That's minus 10. So actually, that's the rate of change per step. That's not the rate of change per 5 steps, it's the rate of change per step. And so if this is 930, I can just plug it in there. So 12,840 24,000 by negative 930. That is 12. Or without the equation, you know the slope is 930. So you can just write 24,000 minus x times 930. And you could just plug in values for for x. So maybe I put x for 5, I get this. Put x for 7, I get 17,000, but I want 12,000, so that's not the answer. I put in 8, it's not 12,840. But if I put 12, it works. So that's how you do it.
Why did you put the opposite as well?
Because you always get the constant when you plug in x is equal to 0. The equation is given by y is equal to mx plus c. And if you put in 0 here, you just replace x with 0. And m times 0 is 0.
Yeah.
So y of 0 is equal to c. And here,
Okay.
h is equal to 0. This is our input. It's the hours. So at hour is equal to 0, this is our 24,000. So I hope that helps. That's very good. You have more questions, by the way? At all? Back. And we can do nonlinear equation. So would you guys like to try this out first?
Teams?
No. This time I've not done that because it's the same topic. It's nonlinear equation, so we're spending 2 sessions on it. Right? So it's getting started. You can try to give this exercise a go. B or already.
Oh,
Already. Very confident.
some news.
Okay, I'll start drawing some stuff.
برضو أنا كنت سادس.
So that's a very well drawn prism. The height is 9. The length is the length. And the width is the width. We are given a fact we still have not utilized yet. That is, the length is 7 inches more than the width. So I can write L is equal to 7 W. That should be useful. And now finally we want a function in terms of the length. So when I say a function in terms of the length, I mean I give you the length, you give me the volume. This is precisely what I mean. I want to have something that looks like this. So it's V of L, which means I input L, I get V. It's equal to something. Now, you want to find the volume, it's usually the length times the width times the height. I hope that is clear. We've seen it before. So length times width times height. This is nice because we know that the height is equal to 11. 9. Oh, sorry, I maybe I misheard that. Yes. So now we have length times width times 9. 9. So at first it looked like a function of length, width, and height, but now it's a function of just length and width. And we want it to be a function of length. And there is one fact that we still have not utilized it. So what should we do?
Plug in length, then
Let's see. So is this what you want to do? You want to put 7 plus W times W. But let me ask you a question. Is this a function of the length? If I tell you the length is 10, can you tell me what the volume is going to be from this equation?
yes.
I mean, yes, but you have to do some work, right?
Yeah.
Yeah, so that's the thing. So this is a function of the width. So this function, this very precise function, let's say I tell you the width is 10. Then you find the volume is just 10 times 9 times 17. But then this is not what we want. We want everything in terms of L. Which means that if I write this width in terms of L, it will give me L minus 7. And so in this case, I get L times L minus 7 times 9. Now here he just uses X. So you can just replace this L with X. So you get 9L times L minus 7. So B is going to be the answer. What do you think? You seem very happy with this problem. I'm glad it made you happy. Sorry. But here the main takeaway is focus on what you want to make subject. So you want a function in length. Here it's very easy. If I tell you the length is 10, you can immediately tell me what the volume is going to be. It's going to be 10 times 3 times 9. And that's what we want. When we say this is a function of something, then this is always what we seek to find. Oops. Maybe I'll give you some time to try this out as well.
بص ما تاخدش على كارت الشغل. مش سهلة. It's a PC. It's like the C it's equals 10 or PC it's equals.
So P of C is 10, and P of C is the value you get when you plug in C.
Okay.
So plugging in C means you remove X and you put in C. So you would remove this X,
Remove this X and put C.
and put C here and C there.
So it's like a 10 minus 10 power of 2 plus 160 over to C. The C is 2 times 10.
It's the C is not 10. 10 is the
P of
value.
C.
Yes, so C is an input.
So if
P
you
of C is
remove
the
X,
output.
yeah. So if we remove X, we should put 10.
No, you should put C. So here's how you should do it. P of C is equal to 10 on one side, but on the other side, P of C by the definition of a function is equal to, so you remove, so if we had x here, you would write x minus c squared plus 160 divided by 2c. But here we don't have x, we have c. So I put this c instead of this x, and I put this c instead of this x.
So the P of the C it's equals 10. So when we put the C, it's not that's not mean that the C it's equal to 10.
Yes, exactly.
So I want the value of the P12.
Yeah, but that's afterwards. But if you look at this, something nice actually happens. Do you see it?
Yes, actually, C is a constant.
Yes, but look at this. Very nice.
Yeah, C minus C.
C minus c is 0.
Yes, that's so we remove.
So we get
So
160
over 2C.
2c or 2c is equal to what?
It's equals to like to 80.
No, it's not equal to 80.
Okay, it's equals 10.
10. So 160 divided by 2c is equal to 10.
Yeah.
Then can you tell me what the value of c will be? 8. Is it 8? What do you think?
I don't think it's not gonna be 8.
Well, let's see how c will look like. So 160. So 160 divided by 2c is equal to 10.
Yes.
Then, well, 160 divided by 2, that's 80, and I'm still dividing by c.
Okay. So it's 80. So that's what I said.
No, it's 80 divided by c is 10.
Yes, 80 divided by 6 is 10.
Yeah, so c is 80 divided by 10.
Yes. So it equals 8.
Yeah, exactly. So we agree on this. Okay, that's
So
good.
that's what we do for if PC is equals 10. But he need the value of P12.
So this is the fact you will use to find P of 12. Because if you try to find P of 12 without finding C, then here's what you get. So you agree with me that P of x is equal to the following. This is just the definition that we're given in the exercise.
So as P12, what does it mean? It's equal to PC or it's PX?
So P12 is the case where you remove x.
And P12.
Yeah, exactly.
So
Right.
P12 and X is 12 minus 2 power of 2 plus 160 over 2C.
Yeah, and the thing is, if you don't know the value of C, you won't be able to make any progress on it.
C is 8.
But now that we know that C is 8, we can solve it.
Yeah, so now 12 minus 8 power of 2.
So 12 minus 8 is 4.
12 minus 8 is 4, 4 power of 2.
So 4 squared plus 160 divided by
2C.
C is what?
So C is 12.
It's 8.
It's 8, I'm sorry, it's 8.
Okay,
So
it's
8
fine.
times 8 is equals like 16 and 4 power of 2.
Yeah,
It's
so
like
4 squared is
16.
16 and this is
16
16.
plus 160.
So this actually, if you just divide it 1 by 1,
So
you get 1
16 with
10.
50. Yes.
16 over 16 is 1.
So yes, that's one.
Yeah, and then 160 divided by 16 is 10. So
So that's the 11.
that's how you do it. So let's say you want to say something. Oh, okay, that's good. So let's say you would like to immediately attempt to find the value of P of 12.
So we should in any if there's any question like this, if there is like 2 answers, so I should discover the first answer and then like put like
You should utilize your given.
Yeah.
If that is what you're asking.
yes, that's right.
Yes. Yes. Not always. So the SAT can sometimes be tricky, but you should always utilize your givens. Now, let's say you try to do this without looking at C. So what you would do basically is this.
I will do basically like this
All you can do.
without all of this.
Yeah. So you write this down, it's correct, but you still need to find the value of C to be able to determine the final answer.
Yes.
And then you realize that there's another given which you still have not utilized. And so you say, okay, let me see where I can go with this. And then I find some progress. And then I'm able to establish a value for C. And then I plug it in, and then we conclude the problem. So how is it for you? You think it's fine? It's good. You can say no. No, that's okay. Okay, sure, that's good. Okay, and this is also another question about the minimum value of the function here. So maybe 30 seconds is okay.
Sì, lo sapevo sono sì.
Yeah, I think this is good. So my function f of x is equal to x minus 2 squared minus 4. And I want to be able to find the minimum value, so the least value I can get. This is a constant, so it won't really change anything. It's not the dynamic part of the function. It just stays as it is. But as for this, this part, this is the dynamic part. This is where all the actions happen. And there is a fun fact we know about squaring things, that if you multiply anything by itself, it's always positive, right? So it's always greater than or equal to 0. And I'm wondering if you can conclude from this. So this is greater than or equal to 0.
It says the minimum value of the function f.
Yeah.
Defined by fx. It's like if it's 2. How we get the
Yeah, that's the question. You say C. How do you know that it's C?
See that the value we plug it in the function, we cannot get the minimum value.
Because so we don't want the minimum point. We want the minimum value.
The minimum value.
So that's equal to, and x is equal to 2, you get that this thing is at its minimum. So this thing is greater than or equal to 0. So its minimum is 0. So the minimum is attained at, the minimum of f is attained at 0 minus 4. So minus 4. We're not looking for the x value which minimizes the function. We're looking for the value we get. So when I tell you I want to find a point which minimizes the function, then in that case the answer would be 2. Because if I plug in 2, I get my 0, and then I get the minus 4. But in this case, we want the value, and in that case, it's minus 4. What do you think? I mean, it's A. Yes. We were just discussing it. So this is always greater than or equal to 0. And this is constant, so this you cannot really change anything about. But my question to you is, at least for the part that's highlighted there, what's the least value this thing can attain? 0. And so for the whole function, it means that if you minimize this part, and that part is already a constant, then you would minimize the whole function. Right? Because this part controls the input, but this part is just constant. So if we minimize the part which controls all the dynamics, then we minimize the whole function. And in that case, we get 0 minus 4, which is minus 4.
We are not looking at the values, we're looking at.
I'm not sure if I understand.
What I did was I plugged in the value of the two positive numbers. And I got 1 for 0 and yeah.
Okay, that's a good way to do it. So let's say you're in the SAT and you have no idea whatsoever how to tackle this problem. You have 4 values. So just pick the one with the least values. So you write x minus 2. So that's another way to do it. Just to put a disclaimer. So maybe, no, that wouldn't work. That wouldn't work because yes, I think I was just explaining that to your colleague. So we're looking for the minimum value, not the minimum point at which we get a minimum. So there's a distinction. So you could say that the minimum is attained at minus 4 for x is equal to 2. Because if you plug in x is equal to 2, you get minus 4. So this is the x value. I know I say value and I mean the x value, but usually x is the point and y is the value. Yeah, it can get a bit ambiguous when you need to focus on what you need to find. So if they tell you the minimum point, then you can actually utilize this strategy. You know, plug in values and all that. This was points. You would choose 2, but it's not. So we choose. That's something. And this is not a horrible problem in its own right. Maybe you can try to do it. You know, they say that if you write down the problem, you're already halfway to doing it. On the SAT, this is what you need, I think. Just write down things.
Yeah, I know, but actually there's something I'm always interested to understand first. I'm just trying to catch it. The equation.
Yeah, feel free.
I don't understand what is the power of x of 4.
Yeah, I'll write it more clearly.
This is fx f of x. It's equals like 1 plus p power of over 100 power of x. But that means that x it's equals 1 plus p over 100. That's the x power over 4. That means that 1 plus yes.
I'm not sure. I think we need to be a bit clear.
Yeah, I say that 1.84 x power power of x over 4. That does mean that f of x it equals 1 plus p over 100. That means that the x is equal to 1 plus p over 100.
Yeah, I mean this is one way to write f. That's your question, and the other way to write f is this.
That's right.
Where p is some number. Now your task is to find approximately the value of p.
What does it mean is constant?
Constant. So a constant is something that does not change. So 2 is a constant. But x plus 2 has an equation. X is a variable. X can be anything. It can be 17 or 25 or minus 774.
A constant number is like 2, 5.
Yes. 3. But x is a variable which can be any numbers. That's the difference. Okay. So here p is some constant, and we need to make progress with it. Have you guys made progress on the problem? Okay. Oh, okay.
Gonna be 21.
21. How did you get that?
Basically, if we saw the given function, which is 1.84, and we say that was like 1 plus 84 over 100.
It's good. So you want to write 1 plus 84 over 100, but this is to the power of what?
To the power of x. That's the power of x.
Are you sure? It's to the power of x over 4, I think.
No, so that is I just like divided 84 over 4, and I got 1. I don't know. Still
It's not.
the correct way, but is it true?
No, it's not. It's not a bad. It's not a bad guess. Yeah. But the only way we can find out precisely if, let's say, we can write this expression as something to the power of x.
We're gonna take the root 4.
You want to take the fourth root? Yes, exactly. So can you try to take the fourth root of 1.84?
Just want to ask something.
Yes.
Why would sentence like 84 over 100?
Uh-huh.
Because p is a constant, like we were saying.
Yes.
So we put 84 instead of p.
We cannot, because here we have a power of x. But here we have power of x over 4.
So it's a variable.
What is a variable?
Yes.
X is always a variable, but what I mean to say is these two are not the same if we compare them. We need the exponents to be the same.
Okay.
So we need to get rid of this 4 somehow. And the idea that was suggested by your colleague Ali is the following. So we write 1.84 the x divided by 4. This is just 1.84 to the 1 over 4 times x. And
Why would type alone?
sorry?
Why would type?
It's just x over 4 is equal to 1 over 4 times x. It's the same thing. I just write the full fraction showing where. It's the same thing. Look at the green part. You think they're the same? No. Okay, that's interesting.
Actually, don't know.
1 over 4 times x is 1/4 of x. Right? That's just what I wrote there. 1. So 1 over 4 times x is x over 4. Okay, I hope that's clear.
Yes.
And now we use a certain law of exponents, which says the following. Okay, you already see the correct answer, but this doesn't matter. The one that it says that if I have a base and it's raised to power of x times y, then this is b to the x to the y. And if you want an explanation for this, it's because b to the x to the y is b to the x times b to the x, so on and so forth. But we do with this y times if you're wondering. But at the same time, by simple law of exponents, if we multiply the bases, we can just add the exponents. So we can just write v to the power of x plus x plus x, x and so on. Also y times. If this step is not clear, I can explain it in the same fashion like this one. But you need to let me know. But then if this is the case, then it's very simple because you get b to the y times x. And then here we can apply the same same formulation, but in reverse. So 1.84 to the power of 1/4 times x is 1.84 to the power of 1/4 to the power of x. And so what we need to do here is we need to first I need to give myself a little bit more space. That's one thing. And the second thing is I can compute this value. So 1.84 to the power of 1/4. We will have the calculator on our exam, so that's fine. So I get 1.164 something power of x. And now I can equate it. I mean, it's always been equal to this expression, but I still need to equate it like this so I can make the proper comparison. And then finally, to conclude, well, 1.164, that's just that's 16.4 over 100. Dot, dot, dot. So that's 1 plus 16.4. And so if you compare these two, then clearly this is going to be the answer. So the trick here to solving the question is just to know this trick. It's this trick. That's one of the laws of exponents. And we can talk about it if you have questions. If you have them. That's good. So I think that's good. Would you like me to move on? Everyone? Okay.
That's good.
That's good. Good. Maybe I'll give you some couple of moments to think about this as well. So this is a nice question in disguise. It looks tough, but it's very soft inside. Maybe I'll give you a hint.
So it's like some do like plus. Do like addition where some like some we do like why we do like some we do that like addition for the powers.
Exactly. So we're doing addition in the exponent.
Yes.
It's very good. Now, what do you see? How much are we adding each step?
It's like 159.
Yeah, so in this step, how much did I add to the exponent? 4.
So like every time we move, it's like 4.
4.
So it's like 1 plus 4 is 5. 5 plus 5 is
So 29 is equal to Well, the starting value is 1, and I'm always adding 4 times, let's say, k in the exponent. No, yes, in the exponent. Okay, k is some value. Because f of x is equal to a to the x, a to the x. This is an exponential function. But okay, let's find this k. So how many times do I need to add 4 to get 29?
4% times.
7 times. So in this case, k would be equal to 7. 7 times 4 is 28, and then 1 gives us 29.
That's the example, right?
Hmm?
That's the example where it's not the answer to the question.
I mean, it looks very similar to the answer to the question.
Yeah, so actually it's like what I want to say how it's like 29, but we did addition like 1 plus 5 plus 9. Why we didn't do this 1 plus 5 plus 9? Or it's actually we see the powers how it like how it's like going.
It's going up, so that's the first off. It's a good observation.
Yes, it's an yes, it's an
Oh, okay.
هو 1 بلس يعني 1 وفات 1 احنا بنشوف هو كل مره زادت كام يعني مثلا الفرق السنتين ما بين الباورز على حسب بقى وبعدين دي مثلا 1 بلس 1 بلس 4 equals 5 1 plus 4 equals like 5 5 plus 5 equals 10 10 plus 4 plus 4 it equals 14 and 14 plus 14 equals 18 18 plus 9 equals like 29, right?
Not really, because you're adding 4 with each step. So if you do like this, you get 5. To add 4, you can get 9, 13, 17, 21, 25, 29. So we're adding 4 with each step. You made a good observation. That's something. Now we need to keep track of x or k. I mean, so we're going 1, 2, 3 until k. We have some idea about k. Is it 7? I don't know. Let's see. Because it might not be 7. So 1 gives me a to the 1. 2 gives me a to the 5, which is 1 plus 4 times 1, right? And 3 gives me 9. A to the 9 is 1 plus 4 times 2, right? And so on and so forth until some value of, okay, not, maybe I shouldn't call this k. Maybe I'll call this t. I hope that's fine. Because it's not our k. So for some value k, okay, I shouldn't write equal. So it's like the table. That's how you should imagine. So if I plug in k, I will get a to the 29, but I'll also get a to the 1 plus 4 times 7. Now, can you conclude from this? I want you to notice the difference between the changing term and make a good conclusion for this problem. So compare the red parts, if that makes sense.
I feel like 7 is like I don't know. It's not 7.
It's not 7.
I feel
Because you need to be careful with counting. So the first term is
it's not counting. It's gonna be 7. It's okay. So it's
no. So we need to write them all underneath each other. Right. That's this. So with 1 I got 1 times 4 to the 0. With 2 I got 4 times 1 to the 1. Okay, no, just 4 times 1. With 3 I have 4 times 2. With 4 I have 4 times 3. With 5 I have 4 times 4, and so on and so forth. And with k, I have always k minus 1. That's the relation. So the first term is when this is 0. The second term is when this is 1. The kth term is when this is k minus 1. So in this case, k is equal to 8, not 7. And this is not, I hope it's not too difficult to see. We have 1 and 0, 2 and 1, 3 and 2, and so on and so forth. And so if you have here k, then whatever is next to 4 is k minus 1. Because you're always taking away 1, like this. That's really what's going on here. And if you make a note of that, then this problem should be easy for you to make progress with. So okay, maybe I should go back. What do you think of this problem? Is it too much? What do you think, Yosef?
Sorry.
What do you think of this problem? Is it too much?
I mean, that's fine. You know, you have to think outside the box.
Yeah, a little bit. Yeah. You just have
Yeah,
to make.
yeah, it's fine.
Yeah. And also you have to be tricky because in the very end, if you say k is 7, then it's a problem.
Yeah.
So that's really what's going on here. I hope that is okay for most of you. I mean, for all of you. I'm not trying. Why would I not hope for you to understand? That'll be very evil. Anyway. Oops, I just unraveled the answer. Anyway, eventually that just go on. So here we have.
Sorry, what was the answer you said? The answer.
The answer was A for the previous exercise. It was
Okay.
8 because we start like this. It's 8 to the 1. It's 8 to the 5. It's 8 to the 9. And this is 8 to the 29. So you notice that with the first step, you're multiplying 4 by 0. With the second step, you're multiplying 4 by 1. With the third step, you're multiplying 4 by 2. And so when you finish all of this, you get that you're multiplying k. So at step k, you're multiplying by k minus 1 of the exponent. And in that case, this k minus 1 is 7. So in that case, you would conclude with this. K is equal to 8. Just a quick overview. Now, would you like to try this problem? It's not a tricky problem.
It's not a tricky. It's graphed, right?
It doesn't have to be. Maybe it's just an instruction.
C or D.
C or D. I think in the SAT you need to choose one. So that's 50%.
Yes.
C. Okay. Would you like to share with us your ideas? Okay.
Because it's the ground.
Okay, but
So generally checking.
it hits the ground, so it reaches X. Can you be more precise?
we draw a line from 0 and 0, go up, down. So when it's reached x is 0, so it's the
So because
so the time it reaches the
so
it's
so what's plotted here in the y-axis?
the height.
The height, okay. And what's plotted here on the x-axis? Time. So let's say the function looks like whatever it looks like. The point at which it touches the x-axis, what can we say about its height?
0.
Yes. And if you have a projectile which has a height of 0, then it hits the ground. That's what Ali is saying. And this logically sound. It sounds good. Are you guys on board?
Yeah.
Okay, that's good. Yeah, this wasn't too tedious. So so here, this is what I was talking about to you. So the function is just a distraction.
Functions.
This function, this very precise function, is a distraction. Like you just give it to you, and if you're, let's say you're a Desmos enthusiast, then you would just go to the calculator, you would plug it in the calculator and see what you get. But it doesn't make sense because you don't need it. You don't need to know what the description of the function is to be able to solve the problem.
Can we use a graphing calculator to put in the equation and the answer?
Okay, let me actually do this. So I will plot this function right now, and then when we are done, I will ask you to conclude. By conclude, I mean I want you to explain to me how you're going to reach the solution from the Cartesian coordinates. So it's good. I want to make what I'm saying very precise. So this is what we will be doing now. We can go full screen. So why not? So this is the graph. Maybe I should zoom out even more. You know, it goes up, down, actually goes down. Okay. Up and down. This is its maximum. This is the graph. How can you conclude from this?
In the proportion, it told us that it is positive and negative, then that means that they basically ask for what that means. So I guess I'm seeing it very literally when it goes down, and that is the x-axis, that's the time, and that is the ground. So it can't go under the ground, and have to be on the ground. So
Okay, that's not a bad way to look at it, but you still need to make the observation that on the y-axis we're plotting the height. Because here's the thing, I can switch them around. So I can do like this. This is unorthodox, but I can do like this, and then ask you about the y-intercept. So I'm switching it around. And then in that case, you would still need to understand what happens when the height is equal to 0. Because the height is on the y-axis. Oh no, the opposite. Because
it could be like this, right?
the time will be on the x-axis. So what I want to say is you need to be careful.
So it could be like this.
It will probably look like this.
Yeah. So come back.
Yeah. something like this. So that's a good note. I don't want to say maybe if you're lucky you will get it.
It's like question.
Yeah, or maybe you just need to read the question carefully, because if you don't, it can really mess with you, and then that's not good. Maybe you would like to think about this problem. Let me write down some facts.
Right?
Yeah.
Already. Okay. You have 2 votes for A. C. What do you think, Omar? Okay, that's not an answer.
كلام الحاجة بس.
Okay. And Darren?
Not done yet.
Oh, we're rushing you. You need to get it going. But that's fine. Let's write some stuff down.
See that? لا. See.
So the population right now is 50,000, and each year it increases by 3%.
See.
So in year 0, the population is 50,000. In year 1, it increases by 3%. How do I write this mathematically? Is a good question, guys. Plus 0.03. So you're adding 0.03. So the population is so it's people.
So it should be.
Yeah, I mean it wouldn't make.
Yeah.
Make
that is big.
Yeah, if you add 0.03 people, maybe you take someone and cut them into 0.03 pieces. But that's really, I don't think that's a good idea. So that's not proceed with it. So probably it involves multiplier. But then what is this quantity?
The whole quantity,
Yes, this 50,000 times 0.03.
that is the number of people in Lebanon.
Actually, you need to be careful. So we know that they are increasing, right? Now, do you know what this value is? So can you compute it? Yeah, I can write it as 3/100. And then if I just take away the zeros,
It is 16.
I get 1,500.
16,650.
Are you sure? No, it's 3/100, not 3/10. What I want to say is, in any of these 2 cases, is that what you're pointing out is a decrease in population. So this can be the solution, right?
Yeah.
But it had to be something. So at least I will get my population back, right? So I will get my 50,000 back. But then I get an increase of 3%, which can be written as 0.03. So that's what happens. You get your population back, and then you add 0.03 to this population. You add this amount of this growth. Okay, what happens in the second year? So you want to add
1.02. Yeah.
like this?
Yeah.
Well, you need to be careful as well. So what is this effectively? This is just y1, y0, sorry. So y0 grows by 3% in the first year. Now in the second year, it will grow 3% from the previous year. So we take this amount from last year. So this is the amount from last year, which is y1. So this is y1, and y1 grows by 3%. So with each year, you grow by 3%. You get the same population back, and it grows by 3%. But then what is y1? Maybe I should put equal signs. In that case, if I just plug in y1, I get y0 times 1 plus 0.03. So this is my original amount. And then this amount has increased by 1 plus 0. Okay, this is 0. This is a double 0.
And then
0.3. And then if I want to do it for the third year, I'll get this thing 3 times. If I want to do it for the fourth year, I'll multiply by 4 times. Because I really want you to focus on what's inside of the bracket. What's inside of the bracket is something, and this thing will grow by 3%. And what this thing precisely is, it's the growth from the previous year by 3%. And then this accumulates, obviously. And if I were to write this in a nicer form, I would write y0 times 1.1 plus 0.03 squared, because I have it twice. I can just write this as 1.03 squared. This happens in the second year, and in the third year, it's 3, and in the fourth year, it's 4, and in the fifth year, it's t. See what's going on? Okay. This y0 again is my initial starting point. So I can replace my y0 with 50,000 that I've written down here. So this is the, I'll erase this because it's a bit misleading. But what do we want to have after t years? Is my question to you. Exactly. So we want to have, after t years, we want to have 60,000 people. So this becomes our equation. 50,000 times 1.03 to t is equal to 60,000. So on one hand, we want y of t to be 60,000. And on the other hand, we find a nice expression for it on the right. And more generally, all exponential equations are usually of the following form. So it's exponential growth, exponential decay. I think we've covered some examples today. Are of this form. So a to the x Yeah. No, what I want to eat, what I want to write. I want to write 1 plus the r% power of t, for example. And then here I want to write, let's say, a0. So this gives us a n. Actually, n plus 1. No, n. Yeah. So there's a starting point 0. And if I accumulate n times, okay, I'm sorry, t times, so t times, then I get the value that is in front of me. The this is the starting value. This is the growth or decay. R can be negative. So I could have a problem where something is decaying very quickly. So in that case, let's say it's decaying. Let's say a tree is falling down by 50% each fall. Then your rate of decay is 50%, for example, in this period of time. And so on and so forth. So I hope this was good. I hope it was easy. Usually it's not easy to do problems like this, but you can do it. I'll be uploading the exercise on Moodle. I've explained to some of your colleagues that the number of questions on the question bank have tripled, which is good news for you, but bad news for me because I have to write them all down. I mean, almost. But this is what I'm working on, and it's the cause of the delay. They will be uploaded very soon. And next Wednesday, we have 2 topics. So that should be interesting. This is the first time we're going to do 2 topics in one go. So let's see how this should unfold. Maybe now is a good time to stop recording. And thank you all for joining. It's been an absolute pleasure. Thank you.